everyone. Today we'll be learning how to subtract in the different number systems. Just to recap, in the previous lesson, you were able to add in the different number systems. What we did was to start off with studying the principle behind decimal addition, and then we applied it to the different number systems. We will do the same in this lesson. So to start off, we have here decimal system. Let's say we have 26 minus 7. Okay? 6 minus 7 cannot be. So what we do, as you have learned in your elementary days, we borrow 1 from the next place value. So 2 becomes 1. And we get 16 here. If we're going to expound this, you are actually borrowing 10. And you are in base 10. Plus 6, that's why you have 16. And 16 minus 7 is now possible. So 16 minus 7, you get 9. 1 minus nothing, you get 19. And you have an answer of 19. We have a second way of thinking how to solve this problem. So we start off with the 1 here, which is your base. And then subtract the 7 right away, which is this one. You get 3. And finally, what we have left here, which is 9, goes here. So plus 9. I'm sorry, plus 6. You get a 9. And that 9 here is the same as this 9 here. You see, there are two methods how to do this. And I would recommend following the second way in subtracting octal and hexadecimal. We go now to octal. Let's just say we have the same example, which is 26 minus 7, but this time it's in octal. Okay. So 6 minus 7 cannot be. What we're going to do is the same thing. We're going to borrow 1 from 2. This becomes 1. And you get a 16 octal. The 16 octal, if we're going to expand this, is we get to 1. It's no longer 10 but 8 because we are in base 8. So we subtract the 7 right away. You get a 1. And then whatever left a while ago, which is 6, is added. You get a 7. Therefore, 16 octal minus 7 is 7. Okay, finally, 1 here minus nothing is equal to 1. Therefore, 26 minus 7 is equal to 17. To make it clearer, let's have another example. Let's say we have 53 minus 15. Still in octal, so 3 minus 5 cannot be. We borrow 1 from 5, that becomes 4. And the 3 becomes 13. To expound it, that 1 there is base 8 minus 5, you get a 3. And then add whatever we left in the minuend. So that's 3 plus 3 is equal to 6. Again, 13 minus 5 is equal to 6 in base 8. And then finally, 4 minus 1, you get a 3. Therefore, 53 base 8 minus 15 base 8, you get a 36. Let's have another example. Let's say you have here 5003. Now we're going to subtract, let's say, 317. Okay. We're still in octal, so 3 minus 7 cannot be. We're supposed to borrow from 0. Of course, you cannot borrow from 0, so we go to the next number where we can borrow. So we are taking the whole thing, which is 500 minus 1. You get a 477 base 8. If you remember, we have an exercise on adding 1 to a number in a particular base. For this matter, we have 477 plus 1, you get 500. Therefore, 500 minus 1 is equal to 477. Okay? And don't forget that we borrowed 1. Let's expand it. So 1 is 8 minus 7. You get a 1 plus what we have left a while ago is 3. You get a 4. Therefore, 13 minus 7 is equal to 4. 7 minus 1, that's possible. So 6. 7 minus 3, you get a 4. And finally, 4 minus nothing is equal to 4. Therefore, 5003 minus 317 is equal to 4464 in base 8. Let me just write the base. There you go. That's how you subtract in base 8. Now, how do we do it in hexadecimal? Let me write here hex. The good thing about that principle a while ago is it is applicable to other number systems. So we apply the same number system. Let's have an example in hexadecimal. Let's say 26 minus 7, the same example as above, but this time it's in base 16. Okay, so 6 minus 7 cannot be. Again, we borrow 1 from 2, that becomes 1. You have now 16. That is 16 base 16. Let's expand this. The 1 there is actually 16 minus 7. You get a 9. And that 9, we add 6, which we left here. The answer is 15, which is actually F in decimal. So 16 hexadecimal, minus 7 hexadecimal is equal to F. Okay, finally, 1 minus nothing is equal to 1. That's how you subtract in hexadecimal. Let's reinforce it by giving another example. Let's say we have 53 minus 15 in hex. Right. 3 minus 5 cannot be, so we borrow 1 from 5. This becomes 4. Okay, let's expand this. So 16 minus 5, you get a 11 plus whatever we left a while ago, it's 3. We get 11 plus 3 is 14. 14 is actually letter E in hex. Finally, 4 minus 1, that is possible, so we get 3 here. Therefore, our final answer is 3E base 16. And that's how you do it in hexadecimal. Okay, let's have another example. Let's say we have B 5 6 minus 2AE. Okay. So 6 minus E cannot be, so we borrow 1 from here. This becomes 4. And we have 16 decimal minus E. Hexadecimal minus E. So let's expand this. The 1 there is 16 because we're still in base 16 or hexadecimal minus E. E here is actually 14. So we get 2. So think of the numbers as if they are decimal when dealing with hexadecimal and octal. Okay. Finally, we left 6 here. So plus 6, we get an 8. And 16 hex minus E is equal to 8. We proceed. 4 minus A, let me rewrite this, that's A, cannot be. So we're going to borrow from B, and this becomes A. Remember that A plus 1 is equal to B. Okay. This now becomes 14. Okay. That 14 can be expanded as 16 minus A, which is 10, is equal to 6. And we left 4 behind, so you get a 10, which is in hex, letter A. Therefore, 14 hex minus A is equal to A. Finally, A minus 2, that is possible. So we think of it as a decimal number. 10 minus 2, that's 8. And we have our final answer as 8A8. And that's how you subtract in hexadecimal. To wrap it up, in subtracting octal and hexadecimal numbers, apply the following tips. First, think of them as decimal numbers. Second, when minuend is greater than subtrahend, borrow 1 from the next significant digit. Borrowing 1 is equal to the base of the number system. Third, represent the numbers 10 to 15 as A to F in hexadecimal system. In the next video, I will discuss signed and unsigned numbers plus subtraction using complementation. I hope you learned something today, and see you in my next video.